Okay, in previous videos, we have discussed three very important concepts related to geovisualization because um, they together they define geovisualization. These concepts are analytic cartography, interactive maps, or interactive visualization, right? Interactive maps, they are part of interactive visualization. And lastly, scientific visualization. So now the question is, how has geovisualization been defined by officials? So here is the definition again from ICA, International Cartographic Association, because geovisualization, you can consider it as an expansion of traditional cartography. All right, okay. So geovisualization integrates approaches from visualization in scientific computing, cartography, image analysis, information visualization, exploratory data analysis, and geographic information systems to provide theories, methods, and tools for visual exploration, analysis, synthesis, and presentation of geospatial data. In summary, geovisualization employs computer science and methods and technologies from GIS and remote sensing. Usually, people think GIS and remote sensing, they are the same thing. Actually, they are not. Okay. Geovisualization uses or utilizes these technologies and methods to visualize geographic data. And what's the purpose of geovisualization, right? To explore geographic data. Firstly, to present them, then explore, then raise questions, right? And do analysis, and then draw conclusions. Okay, so that's geovisualization. And next, I would like to introduce several aspects of geovisualization, including the goals of GeoVis, the driving forces, cognitive aspects, visualization methods and techniques, and usability. Firstly, goals. Okay, so like I said, geovisualization is a combination of a lot of theories and methods, right? So depending on your specific application, your geovisualization can have a very unique goal or a very common goal that maybe all geovisualization um, shares, right? So there are many goals, especially for different forms of geovisualization. But since geovisualization is a form of what? Visualization, we can simply use, how can I say, three dimensions of space of visualization to contain the goals of geovisualization. In other words, you can consider that there is a spectrum for the goals of geovisualization. And when we're using these three dimensions to define a space, this space defines this spectrum. And no matter what geovisualization you are doing, its goal can be found somewhere along this spectrum. Okay, so these three dimensions include task, interaction with the visualization interface, and the visualization use. Okay, so the task can range from revealing unknowns and constructing new knowledge to sharing existing knowledge. Okay, so on this dimension, the two extremes are revealing unknowns and and sharing knowns. Okay, that's the first dimension. The second dimension is the interaction. It can range from a rather passive low level to a very high level of interaction. So on this dimension, two extremes are very low level interaction or no interaction, and and a high level of interaction. The third dimension is the visualization use. It ranges from a single private user to a large public audience. What does it mean? It means that some visualizations, they are for yourself or for your, how can I say, a research team, say that, for your own company, which means that the user is limited to a very small group of people or even yourself. That's called private. That's called private. And on the other extreme of this dimension, your users could be the general public, which means your geovisualization is for a lot of people, not only for professionals like researchers or yourself. It's for the general public. That's the third dimension. So when we put these three dimensions together, what do we have? We have a 3D world, right? A 3D space. And usually we use something called this, something called map use cube to address the goals of visualization, or you can say the goals of geovisualization. So like I mentioned before, now we have three dimensions, right? The first dimension is interaction, information presented or task, right? We can use this geovisualization to review unknown, or we can use it to show already known. That's the first dimension, right? The second dimension is interaction, human map interaction. It ranges from high interaction to low interaction. And the third dimension is audience. Remember that the geovisualization could be only for yourself or a small group of people, or it is published for the general public. Okay, so when you have finished a geovisualization, you can use these three dimensions to find a specific location within this cube, within this three-dimensional space, right? You can quantify or simply choose a position for interaction, another position for for information presented, and another position for audience. And you combine these three coordinates based on the three positions, and you find a specific place or a specific location within this cube, right? And the four visualization goals could be placed along the diagonal, right? So this right line here with two arrows is the diagonal, right? If your visualization can be located somewhere here, somewhere on the bottom left corner of this cube, your visualization is for data explorers, because your geovisualization is trying to what? To show unknown. And the interaction of your geovisualization is pretty high, and it is for private use. So this type of visualization is for data explorers. But if your geovisualization can be located somewhere here, somewhere at the top right corner of this cube, your geovisualization is for data viewers, because it is used to what? To show something already known, and it's for public, and the interaction level is low, right? So it's here. For example, a general purpose map in an atlas, right? You cannot interact with it because it's an atlas, right? It's just general purpose map. You cannot change the location of mountains in real world, right? So it's for public, right? Anyone can read it. The interaction level is low because it's hard copy map. And it is used for something already known, right? If there is a mountain, it should be addressed on an atlas, on a general purpose map. So your users are public, right? They are data viewers, okay? So this is how you use this so-called map use cube to find out the goals and your audience. of your geovisualization. And again, I'm presenting you 4 general visualization goals. They are not only for geovisualization, but for all visualization. If you are trying to do presentation, if your focus is synthesis, your visualization is somewhere here. If you're trying to use the visualization to do analysis, to carry out exploration, right? Then your visualization is somewhere here at the bottom corner of what? Of this cube, okay? So 2 extremes are visual thinking. This is a visual thinking extreme because here you're trying to use your visualization to ask more questions, right? To do exploration. And another extreme is visual communication, just for presentation. This is the extreme, another extreme of this diagonal. You're just trying to show people what we have known, right? You want to show them the fact. And in exploration, where the message is yet to be discovered, there is no optimal map in the beginning. What does it mean? It means that if you're trying to use your geovisualization to explore, to ask questions, to do analysis, at the very beginning, you will make a map or other form of geovisualization, but there will be a process of iteration, which means during this process of exploration and analysis, your original map will be updated again and again and again, right? Depending on the progress of your research, of your exploration, of your analysis, right? This is not going to happen if you only want to publish a general purpose map. For general purpose map, for a city, maybe it should be updated every several years or every decade, but usually we consider it static, right? You don't have to repeat this iteration process every day or every week. But if you're a researcher, you're doing a geovisualization to explore geographic data, you may need to update your geovisualization maybe every hour because you always have results from your analysis. You will change your attitude, you will change your conclusion depending on the exploration you're doing, right? So that's the reason why there is no optimal map in the beginning. You will always have to optimize it or iterate it, update it, okay? And yeah, I want, since we're talking about goals, in geovisualization, we can use a lot of tools and methods to what? To achieve our goals. And I want to introduce a very new or say popular way to do this, to achieve our goals in geovisualization. It's called guided discovery. And sophisticated interactive geovisualization methods are now recognized as useful not only for exploration, but also for presentation of knowledge through something called guided discovery. You can consider this as a method of telling stories with maps. Maps is not maps is not a very accurate word. I should say using geovisualization or different forms of geovisualization. Here I want to show you an example. Of course, you can just explore it yourself. It's called story map from SRA. Okay, the example here is the winner of 2018 story map competition supported or sponsored by SRA. So let's say here, yeah. The topic is the Rohingya refugee emergency at a glance. If we go inside, you can see that I'm not going to go through it very very slow. I'll just go through it very quick. You can say different medias, different types of medias, like photos, videos, text, maps, they're all combined in this story map to tell you a story, to show you the situation and the struggling of these refugees in this Asian country. And at the end, I'll just leave this map to you. At the end, the purpose of this map, of course, the most important one is to show you the situation, the environment, the living environment of these refugees there in this country. But at the end, if you want, you can just donate for them. And this is a very typical example of guided discovery. And by the end of the semester, you will use ArcGIS Online to make your own story map, but it's a very simple one, not like this. But I think this is a very good example to show you what is a guided discovery. Okay, let's get back. So now let's talk about driving forces of geovisualization. There are three of them. The first one is technology, rapid advancements in graphics and display. And the second one is data, because data is like the ingredient of geovisualization, right? If you want to cook something, at least you should have some ingredients, right? Data is the ingredient. If you don't have the data, you don't know how to start a geovisualization, right? Because geovisualization is about using visualization technologies to do what? To explore geographic data. So data is always the most important factor here, okay? And the rise of internet and its development into prominent dissemination medium. Today we can share almost everything online, right? It's the same. We can publish, we can make maps online, we can also publish them online, okay? Let's get to them one by one in detail. First one, technology. So in the past, we focused on abstraction. Success for abstraction makes the world easier to understand, because in the past, we didn't have the software, we didn't have powerful hardware to make the real world real on our PC, right? So what we did was to abstract the real world into very simple elements, like using a cube for building, using a simple linear feature without any rendering for rivers, for roads, right? So that's for the past, abstraction. Today, we emphasize on realism, because today we have tools, we have technology, software, in terms of software and hardware to make the real world real on our PC, right? But you should also know that realism is not perfect. We should not say chase realism. We should not always chase realism, because that we have the technology, we have software, we have hardware, but they are expensive. You should always evaluate if it is necessary to invest on realism. At least in GIS research and most GIS applications, we don't need to make the real world on our PC very real, okay? So unless it's necessary, okay? Although abstraction makes a very simple, not very real word, but if it is necessary, then you should be able to live with that, right? Because it takes less resources, okay? And secondly, data collected by everyone today, right? All the time, everywhere, hence the big data problem. So data used to be a problem, because in the past, the way of collecting data was limited to field work. That's basically that's it. And we didn't have the internet to collect data from people conveniently. So today, data collection is more convenient, right? We can collect people's data from internet from their profiles of Twitter, Facebook, and other softwares. And today, due to the convenience of sharing data, again, this convenience is from internet, even normal citizens, people without formal training, formal scientific training, they can join the scientific community. I'm not sure if you have ever heard a word, a phrase called citizen science. There are a lot of communities like this in this form today. I know that one of them, one of these communities is collecting bird data from normal people. You know, a lot of people, they care about how birds immigrate seasonally, right? And you know, it's very expensive to send people to the field to collect data. So they use data shared by normal people, collected by normal people every day. They share their data from where the community, so scientists can use them. Scientists can use them. But you should also know that there is problem with big data. Big data means that today, when we're looking at, say, a person, we can collect the information of this person from different sources, internet, his work, his life habits, right? Different aspects of these people. But the problem is that the quality of the data is doubtable. For example, I mentioned that bird community, right? Citizen science community. The problem of that community is that the data collected by normal people, they are not with high quality usually, right? Because after all, these people, they have never been formally and scientifically trained. Okay, so that's data we can collect it today conveniently, but we should know that the quality of the data is doubtable. You should be careful with the quality of the data. And when we're dealing with data, computers and human brains, they have their own advantages and disadvantages. We should at least, we're not scientists in computer science or biology, but we should at least be aware of these advantages and disadvantages, right? And also, geovisualization ideally combines the strengths of human vision, creativity, and general knowledge. That's the advantages of human brains with the storage capacity and the computational power of the modern computers. That's advantages of computers, right? In order to explore large geospatial data sets. So today, when we're dealing with data, we should combine the advantages of computers, PCs, and human brains. And lastly, but not least, right? Internet is the third driving force of geovisualization today. It has been shifted from technology-driven to human-centered. Today, the internet is human-centered. Anybody can be the content contributor to the internet, right? Like I said, today, if you want, you can be a contributor of community to the scientific community, right? Using internet. And geovisualization tools need to adapt to their users. This is actually what Esri has been doing. You may know that Esri is a developer of ArcGIS, right? They are now trying to move everything online. We have ArcGIS online today. And later in this semester, you will use it. You can conveniently make maps online and publish directly to the internet, to the audience, to your audience. And also, they are trying to shift from ArcGIS desktop to ArcGIS Pro. And ArcGIS Pro is very friendly, is very internet friendly. Okay, you can, again, a lot of powerful algorithms cannot be carried out in ArcGIS Online. You can use ArcGIS Pro to implement them, right? And then you can publish directly using ArcGIS Pro through the servers of Ethereum. Okay. Okay, I will just stop here. Next part, we will start with cognitive aspects of geovisualization.